Hello everyone, I am Mr. Bilal Al-Ajami, the math teacher in Al-Ma'rifa Private International School. I am attaching the following video that included a grade 12 summary of the class materials that have been covered the previous week. We have two sections. The first section 4.4 about the absolute extrema. Absolute extrema means the absolute, how to find the absolute maximum and the absolute minimum. At the end of this section, any student must know how to find the absolute maximum and the absolute minimum. As a warm up, you know from the second term how to graph any polynomial function or any rational function. So graphically, introduction here. Introduction. From the graph, if we have a graph, assume we have like this parabola. Here the end behavior plus infinity and plus infinity at the left and plus infinity at the right. So here no absolute maximum, no absolute maximum. And we have absolute minimum is 0 at x equals 0. Another example, if you have a cubic, assume we have a cubic here. So here no absolute maximum, no absolute minimum. Another, if we have function starting here, decreasing till here. This is closed interval from -2 till 7, assume. So this is represent absolute maximum, and this is represent absolute minimum. As introduction, this is. And here also it is called relative minimum or local minimum. Means in some interval it's minimum. And in -2 to 0 we have minimum. Local minimum. Here local maximum. This represents critical point. How to find it? Derivative equal to 0. Horizontal tangent line. Here, derivative equal to 0. Here, derivative equal to 0. How to know absolute or local? We look to the y values. We look to the y values. This is graphical. I will start from your textbook, example 1. Find the absolute extrema and absolute minimum of the function on the closed interval from 1 to 5. Before, you must know when we have closed interval, you must have absolute maximum and absolute minimum. It will be either at the end point of interval or at the critical point. And another example, maybe we have function like this. I -2, here we have 7. Start here. So here at the end point, this is absolute minimum is -3 at x equal -2. Absolute maximum is, assume here we have 5, the y value, is 5 at x equals 7. This is at the end point of the interval, we have the absolute max, absolute minimum. Or it will be at the critical point. Also for the closed interval. Here, different color. Absolute maximum is 3 at x equal -1. This is how to find it, derivative equal to 0. And absolute minimum is -5 at x equal 2. This is as an introduction. From this example, you will know if you have a closed interval, you must have absolute maximum, absolute minimum, either at the end point of the interval or at the critical points. Let me start the first example. So step 1, you need to find first derivative equal to 0. The derivative here, 6x squared minus 30x plus 30x equals 0. Take 6 common factor, x squared minus 5x plus 6 equal to 0. Factoring, x minus 2, x minus 3 equal to 0. So this is x equal to x equal 3. And check x equal to, it's included inside the interval. Yes, it's belong. X equal 3 belongs the interval. Yes. If not belong, don't take it. This is step 1. Step 2, I want to check the y values. At the end point of the interval, f of 1, f of 5, f of 2, f of 3. The highest value represent absolute maximum, the lowest value represent absolute minimum. We replace in the original function. 2, 1 power 3 minus 15, 1 square plus 36 power 1. The answer will be 23. 2, 5 power 3 minus 15, 5 power 2 plus 36 times 5. The answer is 55. F of 2, 2 power 3 minus 15, 2 power 2 plus 36 times 2. The answer is at 228. 3. At 3, we replace the original, or you can use your calculator by using the setting calc. 36 times 3, the answer is 27. What is the highest value here? The highest value is 55. So 55 هي absolute maximum is 55 occurs at x equal 5. Absolute minimum 23. Absolute minimum occurs at x equal 1. And if you want, you can check it graphically from any application on your mobile. And here, you know, our classroom, we have autograph. By using the autograph, this is a function. I am checking from 1 to 5. Here I have 1. And here we have 5. At 1, it's 23. This is absolute minimum. At 5, here it's not available on my screen. It's 55. So it's at the end point of the interval. This is represent absolute maximum is 55 occurs at x equal 5. And this is absolute minimum 23 occurs at x equal to 1. And the other is to represent local, relative. Done? This is the first example. Another example. Example 2, also find the absolute extrema. Again, step 1, derivative equal to 0. Step 2, substitute the critical points and the end point of interval. Step 3, the highest value represent absolute maximum, the lowest value represent absolute minimum. The derivative here, we multiply 6 4 over 3x. We subtract 1, it will be 1 over 3. And 1 over 3 times 3, it's 1x minus 2 over 3. This is derivative equal to 0. Simplify here, 24 divided by 3, x minus x minus 2 over 3 equal to 0. Take common factor, we take usually the least power. So we take x minus 2 over 3, open bracket, 8x minus 1. Yx, why we take x here? We divide all the terms, yani x 1 over 3 divided by x minus 2 over 3. A quotient of power of same base, we subtract the exponent. 1 over 3 minus 2 over 3, so the answer will be x. The answer will be x. So 8x. Simplify, all must be with positive exponent. Take it down to change to positive exponent equal 0. So now we get rational equation. Rational equation means the numerator equal to 0 and denominator not equal to 0. Uh, 2 over 3 not equal to 0. Here we solve x equal 1 over 8, which belongs the interval, negative 1, 1, we take it. And here if we solve, so it means x not equal to 0. This is, put it in your mind, this is represent the function is continuous everywhere since the domain here or real numbers. But at 0, the derivative not defined at 0, so it means it's continuous but not differentiable at 0. What does that mean here 0 graphically? At x equals 0, the function is continuous but not differentiable because the derivative is not defined at 0. And it's also belong the interval, so it's represent critical point. Step 3 now, we substitute the original function. F of 1, f of -1 is the endpoint, f1 over 8, f of 0. We replace in the original function. F of -1, it's 9. F of 0, 0. f1 over 8 minus 9 over 8. F of 1, it's 3. So what is the absolute? This is absolute maximum is 9 occurs at x equal -1. Absolute minimum is -9 over 8 less than -1. This is at x equal 1 over 8. We finish the first section main idea. You can look to the graph. I have it here. This is the function on the closed interval from -1 to 1. From -1 to 1. This is absolute minimum. At -1, the value y here 9. So here graphically, absolute maximum is 9 at x equal -1. Absolute minimum is -9 over 8 at x equal to 1. Okay, don't take all the figure, only the closed interval. Yani means starting from here and this is only for checking to be related for the previous sections. More practice make you more perfect. You can go for the Khan Academy to be good and for the exam AB to be ready more. I will take here one example. The absolute minimum, find the absolute minimum on the closed interval occurs at what value of x? Clear? Find the derivative. Find the derivative. Derivative here equal to 0. 6x2 plus 6x minus 12 equal to 0. Here with calculator. So direct use calculator. Mod 5 3. Mod 5 3. 6 equal minus 12 equal. The answer will be x equal 1, which included, or x equal minus 2 also included. Now we substitute f of 1, f of -2, f of -3 endpoint, f of 2 in your calculator. It's better to use the setting in your calculator calc 2 alpha x power 3 plus 3 alpha x power 2 minus 12 alpha x plus 5. Calc 1, the answer minus 2 here. Calc minus 2, the answer 25. Calc, because the time very important in the official exam. Calc 2, the answer equal 9. What's the absolute minimum? The lowest value minus 2 occurs at x equal 1. So now we write here 1 and we can done. And you can make more practice. Let me go to the second section. The second section topic is application on the optimization, all in real life. To take a worksheet about the section 4.4, you can make more practice on Khan Academy and from your textbook from number 7 to number 11. optimization as introduction or real life problems. Here, step one, you must determine which function you want to maximize or minimize. For example, if I want to get a maximum profit, if the function represents a profit, the minimum cost, the maximum area, the minimum service area of some shape, service area, the maximum volume, the minimum parameter, and so on. We have a lot of examples. Today we'll do together 2 examples about the maximum area and the maximum volume. Done? So step 1, you must determine which function you want to maximize or minimize. Take example 1 from your textbook. A garden is to be laid out in a rectangular area and protected by a chicken wire fence. What is the largest possible area of the garden? So here, step 1, my aim to get a maximum area. And here X represent, for example, rectangle, length of the rectangle, X, and Y represents the width. So X, X, Y, Y. So what's the area here? X times Y, length times width. This is step 1, determine which function you want to maximize or minimize. Here I have rectangle. And put in your mind, without optimization or without calculus derivative, so how to make fence of a rectangle if we have 100 feet, running feet, chicken wire is available to fence a rectangle? I have many possibles. يعني maybe you can take, for example, 10, 10, it's a 20, and here 40, 40, yes, it's 100, the parameter 100, and the area will be length times feet square, 400. One of the possibilities, this is. Another example, 20, 20, 30, 30. If you multiply, it will be 600 feet, it's better. The area here, it's bigger from 400. If we take 22, 22, and here 33, 33, can multiply 22 times 33, the area will be 726. Let me check, wait. 22 times 2 plus 33 plus 33. The 100, I have a mistake here. Wait. If you take 22, 22, 100 minus 44, it's 56. Divide by 2, so 28. So if you take here 28, 28, because the sum of the parameter must be 100. 28 times 22, it is 660. It's bigger, best. What's the meaning optimal? Means the best solution. Which one's the best? Till now, I don't know which one's the best. Till now, I have 28, 20, 22, 28. It's the best. But maybe we have another possibility. So by optimization, we can know which one the dimension must be taken for the rectangle to get the maximum area of a rectangle. Step 2. Step 2, all here the parameter, it is 100, 100, 100. So I have given here the parameter of 2x plus 2y, it is 100. Since we have 2 variables, we must eliminate one of the variables. In calculus 1, all the word problem in optimization, at most we have 2 variables. So when we have 2 variables, you must eliminate one of the variables. You find relation between the 2 variables. Here I want to eliminate y, for example. So solve for y. 100 minus 2x. Divide by 2, divide by 2, divide by 2. Y equal 50 minus x. We can say here result 1, result 2. And my thesis in master degree all about optimization. There is some function have 100 variables. Done? But in calculus 1 at most 2 variables, so easy. So now I find the relation y. I put step 3, 2 in 1 to eliminate y. The area equal x times 50 minus x. Now we get function in terms of x only. This is a function, which is a quadratic parabola downward. So the maximum will be represented at the vertex of the parabola. Step 4. Now I want to find the critical point. Step 4. Derivative equal to 0. So 50 minus 2x equals 0. Solve, so x equal 25. Because x represent a length, it cannot be negative. And because the two sides of the length x cannot exceed the total parameter of 100, so here we have constraint or physical restriction. X will be between more than 0 and less than 8. Because if we take 50, I mean. If we take one side 50 and the second 550, so it will be 100. And I have 4 sides, so it's impossible. Done? So at most will be to 50. At 50, it will be rejected. Because here the area, if we put area at 0, it means 0, nothing. If you don't take. And if we put a equal 50, also it will be 0. We can replace to check in the original function. So the critical point will be between 0 and 25. Now I want to check a of a 25, replaceable original, the area, it will be 625 feet square. Okay, 625 feet square. Step 5, all the word problem I want from our student to make second derivative test. This is second derivative test. We need it because if you have word problem, we want to maximum profit and minimum cost. All will be same procedure, but the difference, the sign of the second derivative. Yani if second derivative at the critical point less than 0, it means it's concave down. Concave down, so that's represent maximum. If second derivative of the critical point greater than 0, so it's concave up. The function concave up at that critical point, so it's represent minimum. So here I want to check a prime, it is 50 minus 2x. A double prime equal minus 2, less than 0, so it is represent maximum. And graphically, if you want to see the graph from Khan Academy or from any applications or in your textbook, example 1, this is the shape. This is a parabola downward at x equals 0. At x equals 0. Not working here, pen. Here at x equals 0, the area 0. At x equal 50, the area also 0. At x equal 25 represent the vertex of the parabola, which is 625. Clear? This is another example about the optimization word problems. An open box is to be made from a 16-inch by 30-inch piece of cardboard by cutting out squares of equal size from the 4 corners and bending up the sides. Look to the figures here. What size should the square be to obtain a box with a largest volume? So step 1 in optimization, you must determine maximize or minimize. Step 1 here, I want maximum volume. Volume of a rectangular shape, its length, width, height. When we have here cardboard or as a flat, it's represent 2 dimension. When we're bending up, it will be as a box. Without optimization, we can cut any value from the corners. We can make box, but we are not sure it represents the maximum volume. So our aim to get here maximum volume. Here again, I like to do it here. Initial it's 16. Here initial it is 30, 2-dimensional. If we cut here x same size, so the width will be 16 minus 2x. And here, if we cut from left and right, same side, x, so the length will be 30 minus 2. When we're bending up, the thickness of the box will be x. So it will be 30 minus 2x, 16 minus 2x times x. Here, the function, it's already in terms of one variable, which is x. Okay? No need to find relation between x and y. It's already in terms of one variable. Expand, we multiply by distributive property 480 minus 60x minus 32x plus 4x squared, all multiplied by x. So it will be 480x minus 60x squared, 32x squared plus 4x3. Simplify 480x minus 92x squared plus 4x3. This is a function in terms of x. Here, about the constraint, x also represent length, so it cannot be negative. It cannot be negative. So x must be more than or equal to 0. Because the width of the cardboard is 16, we cannot cut out square whose sides are more than 8. Or the new width, here the width of the box, it will be 16 minus 2x, also must be more than 0. If you solve for x, 16 greater than or equal to x, divide by 2, so 8. X must be less than 8, and x greater than 0, so x will be between 0 and 8. If x equals 0, if x equals 0, replace the origin, the answer will be 0. So it's still 2-dimension. If x equal 8, replace 8, also it will be 0. Because if we cut 8, it's impossible to make box because all will be 16. Or you can check it by substitution. So the critical point must be between 0 and 8. Now I want to make derivative equal to 0. The derivative, again, v equal 480x minus 92x squared plus 4x3. v prime 480 minus 184x plus 12x squared is equal to 0. In your calculator, find the critical the roots. It will be x equal 12 and x equal 10 over 3. Here also rejected, it's greater than 8. It's impossible to cut 12 with 12. The width is 16. So this is the value of x must cut from each corner to get a maximum volume. If I want to know the maximum volume, we replace in the original. Replace 10 over 3, it will be around 726. What's the unit here in the question? Feet, inch cube. Done. Now I want to check, this is represent maximum or minimum. Step 5. Second derivative test. V prime equal 480 minus 184x plus 12x squared. V double prime, it will be minus 180 plus 24x. Replace the critical point. At that critical point, the answer 24. This is 24 bracket 10 over 3. The answer will be negative, so it's concave down. So this is represent maximum. So all the word problem, you must make second derivative test. Have a healthy day for everyone. Good luck for all. And if you have any question, you can ask us next week. Goodbye.